Hello, welcome to another exciting edition of Mathematics being made easy. So today we want to look at the derivatives of the trigonometric identities or ratios. Get to my page again and look for how we came about the sine, the cosine, the tan, and all other identities. So today we want to look at the derivatives. So we have what? Derivatives of what? Derivatives of trigonometric identities. Metric ratios or identities. Ratios and identities. Okay. From our last lesson, we said that the trigonometric identities or the ratios are we have the sine of x, or somebody can say sine theta. Then we also have cos, which is what? The cosine. Sine is, the full word is what? The full word is what? Sine. So the cos is what? The cosine. So let me clean this one. So we have the cosine, but in a short form, we have the what? The cos. Then we also have the tan x, which we also call the tangent. Then from there we have cot x, which we call the cotangent. Then we also have cosec, which we also call the cosecant. Then the last but not least, we have sec or secant, which we normally see that, or we normally call the sec x. So these are the trigonometric identities or the ratios that we have. Now we want to look at their derivative. When we differentiate sine, what are we going to get? When we do the same thing to cos, what will be the final answer? When we do it to tan and the rest of the identities, what are we going to get? So from the first principle, we know that, from the first principles of differentiation. First principle of differentiation. We know that when we differentiate sine x, the answer we are going to get, or the solution, will be cos x. Then when we differentiate cos x, which is the cosine of x, we will get negative sine x from the first principle. So if you don't know how to go about this, kindly check my videos. You will surely find it there. So when you differentiate sine x, you get cos x. Then when you differentiate cos x, you get negative sine x. So let's move forward by learning how to differentiate tan x. So tan x, from the Pythagoras theorem or the right angle triangle, we know that tan x is the same as sine x all over cos x. So this is it. So how can we differentiate this? We use a rule which is called the quotient rule. So what does the quotient rule say? The quotient rule says that dy, which is the derivative of dy dx, is equal to what? We have what? V du over dx minus u dv over dx, all divided by what? V squared. So how do we go about it? So we will let our u be equal to what? Sine x. Then our v will be equal to what? Cos x. So we'll let u be sine x, v be cos x. Now let's differentiate these trigonometric identities that we have. So when we differentiate u with respect to x, so du over dx is what? When we differentiate sine, we'll get what? Cos x. Likewise, when we differentiate this, so we are differentiating with respect to x, so dv over dx will give us what? When we differentiate cos, we'll have negative sign. With that, we are good to go. Now let's substitute what we have here into the general formula, which we call the quotient rule. The quotient rule. What do we have? So our dy now, our dx, or the derivative of what? Tan x, we have a v. What is our v? Our v is what? Cos x. Cos x. What is our du dx? Our du dx is also cos x. So into bracket cos x. Then we have minus here. What do we have here? U. What is u? U is sine x. Sine x. Then we have what? Being multiplied by what? Dv ds. What is dv ds? Negative sine x. So negative sine x. All divided by, we have v squared. What is our v? V is cos. So we have what? Cos x all squared. I hope you are getting the point. Very easy. If you are finding it very difficult, kindly pause the video, go over it again, reduce the speed, play it over and over. You'll be able to understand everything that we are doing here. Now, moving forward, cos x multiplied by cos x. What are we going to have? We'll have cos squared x. Cos squared x. Then we have negative multiply negative. It will give us positive. So positive. Then we have sine multiplied by sine x. What do we have? We are going to have what? Sine squared x. All over cos times cos. Repetition of cos 2 times multiplication. So we have what? Cos squared x. Can you see? Mathematics is extremely easy. If you follow the rules, there is no problem again. Then what do we do now? We know that there is an identity that says that cos squared x plus sine squared x is equal to 1. Is equal to 1. So cos squared x plus sine squared x is equal to 1. So what do we have here? We have this and this. This has what? Cos squared x. 1 over cos squared x. 1 over cos squared x. So let's move from here. From 1 over cos squared x. Then 1 over cos squared x. What is the value? 1 over cos squared, or let's quickly finish it up here. 1 over cos squared x is the same as 1 over cos is the same as what? Sec squared x. Sec squared x. So the derivative of tan, or somebody can go forward by cleaning this and writing on. And write 1 over cos squared is the same as 1 over cos x, still multiplied by what? 1 over cos x. 1 over cos x. So 1 over cos is the same as what? 1 over cos is the same as what? Sec x. Be multiplied by another 1 over cos, which is the same as what? Sec x. So this is multiplication. Sec x multiplied by another sec x. What are we going to get? We'll have what? Sec squared x. So when we differentiate tan x, the value or the solution for that is sec squared x. Thank you very much for this video. Kindly go over, play the video as much as you can so that you'll be able to understand everything that has gone on here. So till we meet again, bye bye for now.